Section 1. The first step to safety. A hazard is anything that has the potential to cause harm. Harm can involve people, property, or the environment. To people, it can cause injury or illness. To property, it can cause damage or destruction. To the environment, it can cause pollution or disruption. Hazards are present at work and in everyday life. Ignoring a hazard increases the chance that something will go wrong. We must identify potential sources of harm before they lead to an incident. A proactive approach is always better than a reactive one. Understanding hazards is the foundation of all safety work. If we cannot see the potential for harm, we cannot prevent it. Use a sharp eye and a questioning mind. Look at tasks, equipment, and surroundings with safety as a priority. Safety tools organize our thinking and our findings. Formal tools build a strong safety culture and a common language for action. Section 2. The hierarchy of controls, a pyramid of protection. The most effective solutions are at the top, the least effective at the bottom. Start at the top. Levels from most to least effective. Elimination, substitution, engineering controls, administrative controls, and personal protective equipment. Elimination removes the hazard entirely. If it is gone, it cannot cause harm. Example, redesign a process so the toxic chemical is no longer needed. Substitution replaces a hazard with something less hazardous. The risk of hearing damage decreases. Engineering controls isolate people from the hazard by design. They do not rely on behavior. Administrative controls change the way people work through procedures, training, and warnings. Example, limit time spent in a high-noise area. Personal protective equipment is the last line of defense. Example, require goggles when handling a chemical. Personal protective equipment is least effective because it relies on perfect behavior and equipment that can fail. Always pursue elimination and substitution first, then engineered protections, before relying on procedures and protective equipment. Section 3. Proactive safety through what-if analysis. It is a structured brainstorming method to imagine what could go wrong and how to respond. Ask a series of questions that begin with the words, what if? Consider processes, procedures, and systems to identify potential accident scenarios, consequences, and existing safeguards. First, gather a small, knowledgeable team of operators, maintenance staff, and supervisors. Second, define the scope, a task, a piece of equipment, or a full procedure. Break the work into individual steps. For each step, ask open what-if questions. There are no bad questions. What if the hose ruptures? What if the receiving tank is full? What if power fails during a transfer? Record each question, the consequences, and the safeguards. Evaluate whether safeguards are adequate. If not, recommend stronger actions. Typical actions include new procedures, equipment changes, and improved training. Assign each action to a specific person with a clear deadline for accountability. This simple practice turns discussion into tangible safety improvements before incidents happen. Section 4. Visualizing risk with the bow-tie model. A bow-tie diagram shows a central loss of control event, its causes, its consequences, and the barriers on both sides. The knot is the moment control over a hazard is lost. Threats on the left can trigger the event, while consequences on the right follow if the event occurs. Preventive barriers block threats. Recovery barriers reduce harm after the event. Example hazard, a tank of flammable liquid. Central event, a loss of containment. The leak. Threats include corrosion, an operator mistake, and a vehicle striking the tank. Consequences include fire, explosion, environmental damage, and harm to people. A bow tie balances prevention and recovery to fully manage the risk. Use bow ties for significant risks with multiple causes and consequences, not minor housekeeping issues. It is ideal for workshops, training, and safety reviews because everyone can see the whole story at a glance. It helps focus, discussion, reveal weaknesses, and prioritize actions. By mapping how measures work together, the bow tie ensures complete risk management. Completing a bow tie is a collaborative exercise that turns abstract risk into a concrete plan. Hazard, driving a forklift in a busy warehouse. Top event, forklift collides with a pedestrian. Threat, the operator is distracted. Threat, a pedestrian steps into the forklift path unexpectedly. Threat, the forklift brakes fail. Preventive barrier, a strict no-phone policy for operators. Preventive barrier, clearly marked pedestrian walkways. Preventive barriers, pre-use inspections and a regular maintenance schedule. Consequences include serious injury and damage to racking. Recovery barrier, staff trained in first aid. Recovery barrier, An emergency response plan with regular drills, recovery barrier, inspection of racking after any impact. On one page, the bow tie shows the full safety strategy, threats, consequences, and the barriers that prevent and recover. Section 6. Digging deeper with root cause analysis. Fixing symptoms is not enough. We must find the underlying causes. Root cause analysis identifies the fundamental reasons problems occur. The goal is learning, not blame. Incidents often result from chains of events and contributing factors. Look at equipment, procedures, people, and the management systems that guide the work. Pareto chart, a bar chart that ranks causes by frequency so you focus on the biggest contributors. Often a small number of causes drive most problems. 5 whys. Start with the problem, ask why repeatedly, and follow answers back to the source. Fishbone diagram. Structure brainstorming under categories like people, processes, equipment, materials, environment, and management. Failure modes and effects analysis examines how each part or step could fail, the effects, and how severe, likely, and detectable each is. Fault tree analysis starts with a specific unwanted event and maps all combinations of failures that could cause it. A hazard and operability study is a rigorous line-by-line review of complex processes using standard guide words. Layers of protection analysis checks whether independent safety layers, in combination, reduce major risks to a low level. We covered hazards, the control pyramid, what-if analysis, the bow tie, and root cause tools. The message is simple: think methodically. A hazard is anything that can cause harm. Once we see hazards, we must act. Use the hierarchy of controls first. Strive to eliminate or substitute hazards before relying on procedures and protective equipment. Be proactive. Use what-if analysis to anticipate problems. For significant risks, build a bow tie to visualize prevention and recovery on one page. Use root cause tools to address problems at their source, not just symptoms. Document actions, assign an owner, and set a deadline. Follow up to confirm the fix is effective. Make these methods routine. This is how a safety culture grows. Consistent use of simple tools by everyone beats rare use of complex tools by a few. Start small. Try a what-if and a bow tie on your next task. Together we protect ourselves and each other, every day.